Welcome to another GCBASIC video. It's actually an insight into how I test PMW, pulse width modulation. It's complex. It's complex across all the PICs and AVRs. And I've had a program that I'm sharing now for quite a while, and it sort of really helps me figure it out when I've got a new chip. And if things don't work right, I've got it debugged so that I can figure it out. So really, it's a low-level insight into the PWM operations. So it's not one for the light-hearted. It's quite technical. So if I show you what's actually running on the PIC, it's actually a Q20, 18F Q20, and it's actually got a fixed signal there, and it's 38 kilohertz at 50%. And there are a few ways in GCBASIC how you can make signals like that be generated. And what you want to make sure is that they all work. And this program I've got does all that. And what it does, I'll show you the result in actual fact to start with. If I bring this terminal in, this terminal is attached on the serial port, therefore you need a serial TTL. And I'm just going to change the font so that you can see it. What it does, it goes through and it actually does some discovery. And it does some discovery against a fixed set of frequencies, which it's going to tell you. And then on the oscilloscope, you can see if it's working or not. If it's not working, this thing will tell you where to go and look. Okay. It's interesting because I had to run this myself. And of course, the new chip, the Q20, did not work. And this program told me where to go and look. I don't have to sort of figure it out anymore. I can just very quickly go in. So what we've got at the top here is a bit of an introduction, and it says that the frequency we're looking for is 38 at 50% duty, and I've got turned on the hardware CCP1. Use it. That's a constant, and use that constant, and use timer 2. And 255 means true. If it was 0, it would be false. So the first thing this program does, it brings up what's called fixed mode operation. And if that doesn't work, then nothing else will. But if it did work, and basically it shows you here the registers that the compiler has actually selected. And all you have to do to make this work is set up your PPS on this particular chip for CCP1, and then you type in PMW on, and a signal will come on. I'll show you in the source code. Here's the source code. I'm going to ignore the PPS stuff to start with, and here's the command. The rest of it is noise because it's all the print screen stuff. It says PMW on and PMW off, and they control what's called fixed mode operations, and fixed mode operations should work. Back to the terminal. It then says, here are some variables that the system is using, and it's actually saying, yep, the system, the PMW selected timer was 2, the duty was calculated as 0. Now that is absolutely right because it's a fixed mode. There is no variables involved. The scripts do it. All the scripts work this out. So basically what it says is after PMW1, the constants are set to the same, nothing's changed the constants, and here are all the registers that it's set. So I can see here that the important one was 105 and that the 50% duty cycle was 53. 53 times 2 is 108. It's approximately 50%. It's good enough for army work. And this here, CCP TMR S0 is set to 5, and you'd have to go and look at the data sheet to figure out whether that was the correct timer, but let me reassure you, it was because it was working. And these variables I spoke about earlier on are still 0 because they haven't been updated. And on the oscilloscope, it will have its start. And then it sits there for 5 or 6 seconds and then turns it off. So why don't we just compile that program up? We'll bring in the oscilloscope and we'll see it come on and off. Let me just move that to the right-hand side, right-hand side, right-hand side. I'll just do that all again. In the middle, on the right-hand side, there's the oscilloscope, and I'm just going to program that. So what it's doing, it's compiling it up, it's downloading it to the microcontroller, and magic will happen. And we'll see this oscilloscope drop to 0 because it's powering down the microcontroller. And on the terminal, we get some inputs. It's just programming it at the moment. There we go. It's just programmed it, and it's sitting there on PWM on. Now it's turning it off, it has gone off on the oscilloscope, yes, and now it's coming back on. So it is 2 runs through, and the second run through is what's called variable mode. And variable mode is actually it's all written in assembler, where the first mode is all written in scripts. So we both need to work. So what does our terminal tell us now, look? Well, our terminal tells us now, it says here, we got down to here, PMW off. After the off, it has a load of constants, they haven't changed, and it leaves a load of registers in a state. But now we're going to move into a different mode, because we're going to issue out hardware PMW1, the same frequency at 50%, or whatever that frequency is. Okay, I will change that to, and then after that, you should see a signal on the oscilloscope as we did the second time. And if it doesn't, if it doesn't work, as the hardware PWM has used the same fixed frequency and duty as fixed mode, it should all work. It should work correctly. But if it doesn't, it's because of the following 3 things. 1, somebody hasn't updated the library. That's only applicable if the particular chip has 1 CCP. And some of the Q chips do have only 1 CCP. So was it that? And I looked at that, and no, this chip has 2 CCPs. The second thing it could be is this particular register set up correctly, and it was not. It was not set because I had failed to put this in the DAT file. So I had incorrectly set up the PMW timer variant in the DAT file. And then only after that would you go hunting around inside of the actual library. So I had forgotten to put in the PMW timer variant. And for this type of chip, it's a 2, and this is documented. And all of a sudden, everything burst into life because it says here, if PMW is working, then all is good. And it shows you the same registers and same constants and the same variables. And look, if you look in here, that's now 105. We looked at that earlier on. And it's now 52. That's because of integer mass. It's even closer. And it's got the same resolution. And the resolution in here is also quite important. So this program is very important. And it's called PMW Discovery. And it's extremely useful. It's up on the GitHub, and it's fully documented, and you can have a play with it. Do enjoy.